So what's the domain of a function? In today's video, we'll be explaining the concept of domains and what the domain of a function entails. Basically, the domain of a function is a set of all inputs over which the function has a defined output. So from this question, f of x equals root x minus 7, the domain of the function means the set of all inputs over which the function f of x is defined. This means the set of values in which the expression x minus 7 is not less than 0. This means that the expression could be equal to 0 or greater than 0, but the expression should not be less than 0. This means to solve this problem, we will have x minus 7 greater than or equal to 0. In order for f of x to be defined for the input x, the expression x minus 7 has to be greater than or equal to 0. It shouldn't be less than 0. Now what we are going to do here is make x subject of formula. And to make x subject of formula means to make x stand alone. So we are going to take minus 7 to the right hand side, and this becomes x greater than or equal to 7. What this further entails is that f of x is defined for all inputs that are greater than or equal to 7. This is the only point in which f of x is defined. In a nutshell, this further entails mathematically that the domain of this function is a set of all x that are members of real numbers such that x is greater than or equal to 7. Let's solve another example to aid easy understanding. This question reads, f of a is equal to square root of 2a squared minus a minus 1. We are required to find the domain of this function. Never forget this. Whenever we have a square root function, the function is true, provided the expression under the root sign is either 0 or greater than 0. In a nutshell, what this implies is that the expression under the root should not be less than 0. It should either be equal to 0 or greater than 0. Having gotten that basic concept, let's proceed. We are going to have zero. Remember, this is the basic concept. At this point, we are going to square both sides. And when we square both sides, the square of 0 is 0, and square will cancel our square root. We are going to have 2a squared minus a minus 1 greater than or equal to 0. At this point, looking at the expression in our left hand side, we will have to factorize the quadratic expression. And one of the things I usually advise people is to use the magic cross rule. To get your values, your factors, let's use the magic cross. Now, this rule states First, that you need to look at the coefficient of a squared. What are two possible numbers that you can multiply to have the coefficient of a squared? Here the coefficient of a squared is 2, and of course 1 times 2 is 2. So we can have 1 here and 2. Then we add a's and a's. Proceeding further, the constant here, which is 1, the two factors that can actually multiply to give us 1 is just 1 and 1. So we are going to have 1 and 1. This means that 1 times 1 is 1. And this other side, this means 1 times 2 is 2. Now, look at this sign. We are having a negative sign here. Remember, minus times plus equals minus. Hence, we are going to use minus and plus here. That becomes our answer. So this further yields is minus 1, 2's plus 1 greater than or equal to 0. A subject of, so to make a subject, we are going to have that a is equal to 1 equal to minus 1. To make a subject of formula means to make a stand alone. Dividing both sides by what is standing close to a, we are going to have over 2 over 2. Therefore, we could say that our a or a's is greater than or equal to minus 1 over 2. That becomes our answer for this very step. Now from this point, we can see that two values are minus 1 over 2 and 1. So we are going to take this to our number line. Taking this to our number line, we must always start from the smallest number to the biggest number. This is as shown. We simply impute the values minus 1 over 2 and 1, bearing in mind that a number begins from negative infinity to positive infinity. Now, this is how to solve this problem. From here, we have minus infinity to minus 1 over 2. What is a possible number that exists in between minus infinity to minus 1 over 2? Negative 1. Then, we are also going to ask ourselves, why are we putting negative 1 here? It's because this is the value we are going to use to test the expression to see if this interval is valid or not. Please stay tuned as we proceed. Looking at this other interval from minus 1 over 2 to 1, what is a possible value that exists between minus 1 over 2 to 1? Is number right here. So let's stick with 2 right here, since it exists in this interval. Now let's proceed. Into our f of x, and of course As we can remember, our f of x is, we can remember our f of x yields square root of s minus 1 into 2s plus 1. Remember, this is the same thing as 2s squared minus s minus 1. But don't forget that we factorize that expression. So we are going to put s equals to minus 1 into this expression. Wherever we have s, we are going to put minus 1 to see if it is valid or invalid. For the expression to be valid, the endpoint of the expression has to be greater than 0. Minus 2 times minus 1 is 2. Hence, we can say that this is valid. The expression is valid. Why did we say that it is valid? Because square root of 2 is greater than or equal to 0. So, looking at this boundary, this further explains to us that this interval is valid. The interval is valid. Now, let's try the second interval from minus 1 over 2 to 1. We are going to put 0 into this very expression. So let's try to put 0 into that expression. -1. So minus 1 times 1 is -1. So what we can see from here is that our result is square root of -1. That is highly invalid because the expression is not greater than or equal to 0. So at this point, this particular expression is invalid. So we are not going to consider it. So this very expression is invalid. We are not going to go with it. Going back to our number line, we can see that from this very expression, the interval minus 1 over 2 down to 1 is invalid. And of course, we know 2 minus 1 is 1. And 2 times 2 is 4 plus 1, which becomes 5. And 1 times 5 is equal to 5 is actually valid because the number that exists between this interval, which is 2, actually gave us a result that is greater than or equal to 0. Now, looking at this number line, we have for the first boundary minus infinity to minus 1 over 2, and for the second boundary minus 1 over 2 to 1, and the last boundary 1 to infinity. I am going to explain the concept of interval. Now, an open interval is one which does not include its endpoint. At this particular number line, you don't know the real end value of negative infinity. So at that point, you are going to use an open interval. At that very point, you are going to use an open interval. This means that at this point, this is an open interval. However, looking at minus 1 over 2 here, the number minus 1 over 2 is considered a closed interval because it represents a specific value on the real number line. It represents a specific value. Now, this is not an infinite element in so therefore, our answer, which is the domain of the function, is going to be square brackets 1 comma infinity open bracket, because that is an open interval. Negative infinity minus 1 over 2 and 1 comma infinity. To further assess your level of understanding, don't forget to send in your solution in the comment section below. Kindly subscribe to my channel. See you in our next video, where we'll be solving a lot of complex problems and also giving some quizzes to assess your level of understanding. Thank you.